Today we're going to solve as many problems as we can from recent past questions on GRE. So for this particular question, let's want us to recall the Pythagoras theory, which I can state in this form. This is ABC. And we say if c squared is equals to a squared plus b squared, then the angle here, let's call it x, then x must be equals to 90 degrees. But if this is not correct, then this is not correct, and I'm going to apply that here. So let's look at this, and let's apply the same theorem here. So let's do 13 squared, that's equals to 5 plus x squared plus 12 minus x all squared. And let's pick a condition where x is equals to 0. This implies that 13 squared, this is equals to 5 squared plus 12 squared. And is this correct? Yeah, this is because 13 squared is 169, 5 squared is 25, 12 squared is 144, and this is correct. So because it's correct, this simply implies that the angle here, which is y, is going to be equals to 90. So with this, for this condition of x equals to 0, point A and point B are equal. Let's see when x is not 0. So let's say x is equals to 1. What do we have? This will be 13 squared equals to 5 plus 1 all squared plus 12 minus 1 all squared. This is 13 squared is equals to 6 squared and plus 11 squared. And 13 squared is 169. This is 36 plus 121. And this is simply 157. So clearly 169 is not 157, which implies that the angle is not 90 degrees. So we found a result that the angle is not 90, and here that the angle is 90 for different conditions of x. So that simply means that we cannot necessarily determine the actual relationship between point A and point B, because it could be greater, it could be equal, it could be less. So the answer for this question is simply D. So D is the answer to this. For this second problem, we're given that BCDF and ABDE, they are all squares, and point A is 2 times the area of the shaded region, and point B is 3 times the area of BCDF. So let me just redraw this. Yeah, so these are all squares. So that means if this is A, this is A, this is A, this is A, this is B, this is B, this is B, and this is B. So you can see that here is BD. That simply means that BD here, this will be the side, this will also be B, and these are all angle 90, right? They are all squares, okay? So what is the area of BCDF? So the area, this is simply A times A, which is A squared. Okay, so 3 times the area of BCDF, this is simply 3A squared. Okay, so what about the area of, but here we are looking for the shaded area. And what's the logic behind this? It simply means we're going to find the area of this square, and then we'll subtract the area of this shaded region. And what is the area of this shaded region? This shaded region is simply half of the area of BCDF, which we already found to be A squared. Okay, so that means this region here, this region we're seeing here, it is BDEF. This is simply A squared over 2. Alright, so all we need to do is to find the area of this whole square and subtract this. So what's the area of this? The area of this is simply B times B, which is B squared. So that means the area of the shaded region is just going to be b squared minus a squared over 2. A squared over 2. And that is, at this point, we will have to find A and B in terms of each other. And we can do this by using just this triangle we have here. Okay? And I'm going to redraw that. So I'm just going to, this is angle 90, this is A, and this is B. And by Pythagoras theorem, B squared is equals to A squared plus A squared, which means that B is simply the square root of 2A squared, which is square root of 2 times square root of A squared, which is A root 2. So B is equals to A root 2. We can substitute this into this formula for the area of the shaded region, which is b squared minus a squared over 2. But b is a root 2. So this is going to be a root 2 all squared minus a squared over 2. And what is this? This is simply 2a squared minus a squared over 2 over 1. What's the LCM here? This is going to give us 4a squared minus a squared, and this is 3a squared over 2. So this is the area of the shaded. Okay, this is area of the shaded. So what do we need here? Quantity A is twice the area of the shaded. So that means this is quantity A is simply going to be 2 times 3a squared over 2, and this will give us 3a squared. So let's put that back in here. So this is simply 3a squared, and as you can see, these two are equal. So that means the correct option for this is C. Point A and point B are equal. For the third problem, we are given a line and the xy plane coordinates passing through these various points. So let's just make a rough sketch of the xy coordinates. This is positive y, this is positive x, this is negative x, this is negative y. So the first point is 5, 4. So this is 5 and this is 4. That means this is a very rough sketch. They meet at this point. The next point is 2, negative 1. So this is 2. This is negative 1. That means they met at this point. So we're going to join these two. And from this alone, we can tell that this is a positive slope. How do I know? One way to recognize a positive slope is if the upper part of the line is tending towards the right. This is your right and this is your left. So if the upper part of this line is tending towards the right, it is positive. If it's tending towards the left, it's negative. So for a negative slope, if we have something of this nature, this is a negative slope. This is a negative slope because the upper part is tending towards the left. This is a negative slope, right? This is a positive slope. This is a positive slope. This is a positive slope. So because this slope is positive, we know it is definitely going to be greater than 0. So with that, we know that the relationship here is this. So option A is the correct answer. For this problem, we are given that the area of this circle is 225 pi, and then that the angle here, ABC, is greater than 90 degrees. So let's work with what we have already. So the area of a circle is pi r squared and is given to be 25 pi. We can divide both sides by pi, and what we'll have left, this will result to r squared is equals to 25. If we find the square root of both sides, we'll have that r is simply equals to 5. And this implies that the diameter is 2 times r, which is 10. So our diameter of this circle is 10. And mind you, the diameter is the longest line that joins 2 points in a circle, and it must pass through the center. So if we have a circle, and this is the center, this is a diameter, this is a diameter, this is a diameter, okay? Any other line that crosses, that goes this way, that doesn't cross the center, is called a chord. and a diameter is longer than a chord. A chord is always shorter than a diameter. One more thing I want to call your attention to from circles theorem is that when you have a diameter and you draw two lines from the two edges to meet the circumference of the circle, this angle here must be 90 degrees no matter how you do it. This is 90 degrees. So long as the baseline is a diameter, this must be 90 degrees. And if it is not drawn from the diameter, it's not going to be 90 degrees. So let me just redraw this. So we have our circle here again. This is the center and this is the diameter. Okay, so any other line that is not a diameter is not going to make 90 degrees. That means, for example, if I have this line here and I join it up here, this is going to be less than 90 and this is going to be greater than 90. So from what we are given, this angle here is greater than 90. That means that this line AC is not a diameter, rather it is a chord, and the diameter is always, the diameter of a circle is always greater than the chord. Okay, it's always greater than the chord, and the diameter here is already 10. So that means this line AC, it must be less than 10. All right, and that simply means that quantity B, which is the diameter 10, is greater. So our correct answer is, for the next question, we are given that the length of a side of a regular pentagon with a perimeter 12.5. A pentagon has 5 sides, and when you hear the word regular, that means that all the sides are equal. So if this is A, this is A, this is A, this is A, this is A. And what is perimeter? Perimeter is adding the sum of the lengths. So this will be A plus A plus A plus A. This is 5A. This equals to 12.5. And if you divide this by 5, divide this by 5, I have that A is simply 2.5. Over here we have that the hexagon, which is a side with a shape with 6 sides, and when it's regular, that means all the sides are equal. So this is B, 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 and the perimeter is sum of all the sides, which is 6B is equals to 15. Divide both sides by 6, you have that B is simply 2.5. So that means quantity A that we are comparing is 2.5 and this is 2.5. So that means these two quantities are equal and C is the correct answer. Quantity A is the area of T and B is 64. And they said that the square T is on the XY plane and it has one of its points at 2,2 axis coordinate, and the diagonal intersects at point 6,6. So let's draw this out. This is your XY plane, this is your Y, and this is your X. And this is the square T. This is the diagonal, and this is the diagonal. And the two diagonals intersect at coordinate 6,6. So this means this is 6, and this is 6. And the square has a point at 2.2, which logically this has to be that point, and this is 2 and this is 2. So if you look at this, the distance from here to here, this is 6 minus 2, which is 4. That simply means that this is 4 too, because this is simply half the length of the square. So this tells us that the length of the square is 4 plus 4, which is 8. So this is 8, this is 8, and this is 8. So point A, which is the area of T, is 8 times 8. That is 64. 64. So this is 64, and this is simply equal to 64. So the correct answer for this is C. Point A and B are equal. So for this particular problem, the length of each side of a rectangle R is an integer, and the area of R is 36. Point A is the number of possible values of the perimeter, and point B is 6. So we have a rectangle with an area R which is 36. So the area of R, which is length times width, this is simply 36. Okay, and and length and the width are all integers. So that simply means that we can easily find different values of L and W that will multiply itself, that will multiply each other to give us 36. So the possible numbers could be 36 times 1, the next one 18 times 2, the next one 12 times 3, the next one 9 times 4, they are going to give us 36, and the next one is 6 times 6. And what is perimeter? Perimeter is length plus width times 2. So if this is one of the conditions, this will be 36. Let me put this here. Perimeter is 2 times length plus width. So here the length is 36 and the width is 1. So the perimeter here is going to be 36 plus 1, that is 37 times 2, which is 74. So the perimeter here is 74. For this will be 18 plus 2, that is 20 times 2, which is 40. For this will be 15 times 2, that is 30. This will be 13 times 2, that is 26. And this will be 12 times 2, that is 24. So we have 5 different possible values of the perimeter of this rectangle R. So that means the quantity A here is just 5 possible values, and which simply means that quantity B, which is 6, is greater than quantity A, and the answer for this is simply B. For the next one, we have that X, Y, and Z are the lengths of the sides of a triangle. So we want to compare these two, but let's put this together. This is X plus Y plus Z. We don't know what is the relationship here. This is 2Z. We can subtract Z from both sides, and this will give us X plus Y, and this is Z. Okay, and we know this is just in the form of a triangle of this form. It doesn't matter what the shape looks like. This is X, this is Y, and this is Z. And there is a law that guides triangles, which states that the hypotenuse of a triangle can never be greater than the sum of the other two sides. So if I add this plus this, it must be greater than Y. So X plus Z must be greater than Y. X plus Y must be greater than Z, and Z plus Y must be greater than X. So you can never find a triangle that has a length of one side that is greater than the sum of the other sides. So with that being said, we know that this is definitely greater than Z, because this is two sides and Z is just one side. So quantity A is definitely greater, and the answer here. So here we're given that the radius of the circle S is 12 greater than the radius of the circle T. So what that means, that if RT is the radius of the circle T, that means that RS is going to be RT plus 12. Okay, and quantity A is circumference of circle X minus the circumference of circle T. What's circumference? Circumference is 2 pi r. So let us find what quantity A is, which will be 2 pi rs minus 2 pi rt. Okay, and here we know that rs is rt plus 12. So this would be 2 pi open bracket rt plus 12 minus 2 pi rt, and we can open up this bracket. We have 2 pi rt plus 2 times 12, that's 24 pi minus 2 pi rt. Okay, and this will subtract this. So what we have left is 24 pi. So that means the quantity A is 24 pi, and we're comparing this to 72. We don't know what the relationship is here. We can divide both sides by 24, this by 24, and what we have here is just going to be pi and 3, and we know that pi is 3.16 and so on. So clearly pi is greater than 3. So quantity A is greater than quantity B. For this particular problem, we are told that AB is equals to BC. So AB is equals to BC. That means it's an isosceles triangle. And what this means is if the angle here is x, that means the angle here is going to be x. And the sum of angles in a triangle is 180 degrees. That means 40 plus x is going to give us 180 degrees. This is 40 plus 2x is 180. Let's subtract 40 from both sides. We have 2x is equals to 140. Divide by 2, we have that x is simply 70 degrees, okay? And then that will now bring us down to point A. At point A, we have that angle on a straight line is 180, which means that y plus x is 180. So y plus x has to be 180, and we already know that x is 70 degrees. So this would be y plus 70 equals to 180. Subtract 70 from both sides. We have that y is simply 110. So let's show quantity A is 110, and this is definitely less than 120. So the answer to this, solution to this is B. Quantity B is bigger. For this next question, quantity A is the length of a leg of an isosceles triangle with area R, and quantity B is the length of a side of a square with area R. So an isosceles right triangle, that means it has an angle 90 degree here, and this side are equal. And what that means is that this angle and this angle are equal. So if this is A, this is going to be A, and the area of this is R. And for quantity B, this is also a square. We can call this L, and the area is R. So let's find the area of these two. We know the area is going to be R. So let's say, so our R is half base times height, which is the area of a triangle. So that means R is equals to, what is the base here? The base here is A, and the height is also A. So this is the base and this is the height. So this means that R here is equals to 1 over 2 A squared, which is just A squared over 2. For the square, the area of a square we know is length times length, which is L times L, which is L squared. So we have that R here is L squared, and also R here is A squared over 2. So we can equate the two, which simply means that L squared is equals to A squared over 2. Find the square root of this, find the square root of this, because and they are all positive. So we have that L is simply A over root 2. So now we have that L is equals to A over root 2. So what are we exactly comparing? The length of one of the legs here, this is A, and this is L. And this L is A over root 2. So I can easily replace this with A over root 2. So we're trying to find the relationship between these two. But clearly you can see that quantity A is bigger, and that is because root 2 is greater than 1. So when you divide a number with a number by a number greater than 1, it's going to reduce the value of that number. So A, this value must be less than A. Okay, because we're dividing A by a number greater than 1. So for this particular question, the solution is A. And if you doubt me, I can expand it for you. This is A and A over root 2. We can multiply both sides by root 2. Say times root 2. Say times root 2. We'll have A root 2. This will cancel this. A. Next thing we can do here is we divide both sides by A. Divide by A. This is root 2. And what we have here is A over A is 1. So root 2 is 1.414 and so on. So this is 42. So this is greater than 1, which is what we got earlier on. So for this particular question, we are asked to compare quantity A and quantity B. And if you look at this carefully, you can see that this is 44 degrees. And this angle here has to be 90 minus 44, which is 46 degrees. So this is 46 degrees. And this is A and B. So if I trace this all the way down here, and throw this all the way down here, what I will have here is B, and what I will have here is A. Now, a simple trick to know the one that is bigger is just looking at the angles. This is 46 degree. It is facing this side, okay? And the magnitude of this is B. 44 is facing this region and the magnitude is A. So clearly, the side facing the bigger angle has to be bigger in magnitude. So that simply means that the magnitude of B is greater than the magnitude of A. Alright? Because if you look carefully, you can see that this is negative x-axis and this is negative y-axis. So that means that because the magnitude of B is greater than the magnitude of A, it doesn't necessarily mean that B is greater than A. It simply means that the magnitude of B is bigger than that of A, and because these are negative numbers, so we could just put a number ahead. So if this is 10 and this is 9, this is negative 10, this is negative 9, and negative 9 is greater than negative 10. I hope that makes sense. So which clearly states that A is greater than B. Alright? Yes, the magnitude of B is greater than that of A, but because these are negative numbers, A has to be greater. Let me give you an instance. So let's say B is negative 9 and A is negative 4. Magnitude of negative 9, which is, and then magnitude of negative 4, this is 9, this is 4, and this is greater because we are doing the magnitudes, okay? But in real terms, A is greater than B because the greater the negative number, the smaller the actual value. So the answer to this question is A. A is greater. Don't make the mistake by thinking that B is, because this is just the magnitude of B. They are all negative numbers.